Over the last month, AI has been moving faster than anyone can keep up with. We've seen a so-called free model claim to be 100 times smarter than ChatGPT, and even humiliate GPT-5 in head-to-head tests. OpenAI's own leaks pointed to something wild called YOFO, Wildflower, raising the question whether it's the next big open source move. On top of that, Google has been dropping bombshells left and right, first showing off a self-improving AI agent that crushed deep research, then introducing a system called MAD that could reshape the internet forever, and unveiling Mangle, a reasoning language so powerful it already feels like the future. We also watched robots cross a terrifying new line in intelligence, with Boston Dynamics upgrading Atlas with a brain that changes the game, while Unitree revealed its new flagship humanoid, and somewhere in between, 7 shocking new GPT-5 features landed that people can actually use right now. Put all of this together, and it's clear this month hasn't just been busy, it's been a turning point. So let's talk about it. Something huge just dropped in the AI world, and it did not come from OpenAI or Google. A tiny startup in Singapore just unveiled a new AI agent called HRM. And it might be the biggest breakthrough in reasoning we have seen in years. It is not bigger, it is not trained on more data, instead it is built different. And somehow, this brain-inspired model is outsmarting models over 4 times its size. See, models like ChatGPT break problems down step by step, but one small error can throw everything off. HRM takes a completely different route, thinks in loops like the human brain, and the results are shocking. Now, before you think this is just another tiny model beats GPT headline, this one actually holds up. HRM is not a scaled-down large language model, not a stripped-back transformer, and definitely not just a slim version of ChatGPT. It is something entirely different. It mimics the brain. Not in the generic, oh, it is a neural network way. This one literally borrows the brain's layered decision-making strategy and applies it to artificial intelligence reasoning. And somehow, this architecture lets a model with only 27 million parameters beat models with over 100 million or even billions. Let us put that in context. GPT-1 had 117 million parameters. HRM? 27 million. That is less than 1/4. But here is the kicker. It outperforms Claude 3.7 and OpenAI's O3 Mini High model on reasoning benchmarks. Most modern artificial intelligence models rely on something called chain of thought prompting. Basically, it is like the artificial intelligence is talking itself through a math problem, step by step. Sounds clever, and sometimes it works, but the thing is, if the artificial intelligence makes just one mistake in that chain, the whole answer can fall apart. HRM skips that completely. It does not rely on hoping the chain holds. It reasons more like a human by thinking strategically and then executing rapidly. So how does it do that? Well, HRM has 2 parts that talk to each other. There is a high-level planner and a low-level worker. The planner is like the slow, strategic brain. It maps out the big picture, tries to figure out what kind of problem it is facing. The worker is the fast processor. It takes orders and does the actual work quickly and efficiently. Think of it like a chess master planning a strategy and an assistant executing the moves instantly. These 2 parts loop through each other. The high-level module makes a plan, the low-level module carries it out and sends back results, and then the high-level updates based on what happened. This back and forth continues until the model settles on the answer. This is not just a gimmick, it is built into the architecture, and it gives the model something that most others do not have, a way to internally check and refine its own reasoning mid-process. And the results are pretty insane. The ARC-AGI benchmark, basically an intelligence quotient test for artificial intelligence. HRM scored 40.3%, that is above Claude 3.7's 21.2% and OpenAI's O3 Mini High model, which got 34.5. These are not small differences. This is a tiny model running on one graphics processing unit, beating out some of the biggest names in the game when it comes to raw reasoning. Let us take it a step further. HRM was tested on Sudoku, hard and extreme levels. It solved 55% of them. You want to guess how Claude or OpenAI's models did? 0%, not a single one. And then there is the maze challenge, 30 by 30 grids. HRM found the optimal path in 74.5% of the tests. The others, again, zero, all this. And the model was trained with just 1,000 examples per task. No massive internet data sets, no months-long pre-training. Guanwang, one of the minds behind HRM, said you could train it to pro-level Sudoku in 2 graphics processing unit hours. 2 hours. That is not just efficient, that is ridiculous. But there is more to this than just performance on benchmarks. The way HRM is built solves some deeper problems that current transformer models face. Let us take a step back. Transformer-based large language models like GPT or Claude work by processing a set number of steps for each output token. They always do the same amount of thinking, regardless of how hard the question is. They cannot say, hey, this is a tough one, let me think longer. They do not have the ability to go back, rethink, or rewrite their output once it starts coming out. Once they generate a token, they are locked into it. It is like trying to solve a math problem by writing down one number at a time in pen, without ever checking if you are on the right track. HRM breaks away from that limitation. Its 2-level architecture lets it adapt the amount of reasoning based on the complexity of the problem. In fact, there is even a version of HRM that uses reinforcement learning to decide on its own how many iterations it needs for each task. So for simple tasks, it might only loop a few times. For harder ones, it loops more. This makes it way closer to actual flexible thinking than anything else we have seen, and because of how it is structured, it also avoids one of the biggest issues in artificial intelligence training today: deep back propagation through time. Most models need to remember and synchronize partial derivatives across multiple layers and time steps. It is memory intensive, it is slow, and it is probably not how biological brains actually work. HRM, on the other hand, uses more local gradient updates, which are easier to compute and way more biologically plausible. Now, does that matter in practice? Absolutely. Less memory required means you can run more models at once or train faster with fewer resources. It also means this thing scales really well. You could run HRM on a laptop or even embed it into edge devices or robots. And that is exactly what Sapient is doing. They are already testing HRM in healthcare to help diagnose rare diseases and in seasonal climate forecasting, where it reportedly hit accuracy rates of 97%. The startup's team includes former engineers from DeepMind, Anthropic, DeepSeek, and even Elon Musk's xAI group. These are people who have worked at the cutting edge of artificial intelligence, and they are all betting on HRM's brain-inspired design to eventually push past the limits of what we have come to expect from large language models. And yeah, they are not shy about it. Guanwang straight up said, artificial general intelligence is about giving machines human-level intelligence and eventually beyond. Chain of thought prompting is just a shortcut. What we have built is something that can think. That kind of confidence usually comes from people trying to sell you hype, but in this case, the results are backing it up. You do not have to just take their word for it either. The entire project is open source. You can check it out yourself right now on GitHub. Train your own version, modify it, see how it works. That level of transparency is pretty rare, especially for something this promising. Now sure, it is early days. HRM still has a narrow focus. It is built to reason, not to chat. Do not expect it to write poetry or summarize your emails. But as a proof of concept, it is one of the strongest we have seen. And HRM is not alone. There are other architectural breakthroughs being explored. Sakana is working on continuous thought machines. There are bit-level large language models that only use 1-bit weights. Even Google is testing out diffusion-based reasoning models. All of these are still in the experimental phase, but they are part of the same trend. Rethinking how artificial intelligence should actually work instead of just making it bigger. What is different here is that HRM is already working. It is already beating models 4 times its size using just a tiny sliver of the training data with no pre-training at all. It is not just theory anymore, and honestly, unless someone suddenly throws a few billion into building a new foundational model from scratch, the next big artificial intelligence leap probably will not be another scaled-up GPT clone. It will be something like this. A totally new architecture that brings better reasoning, faster training, and cheaper deployment without needing a warehouse full of graphics processing units. If HRM's path continues, it could be the first step toward a world where artificial intelligence agents do not live in data centers. They live in your laptop, in your robot, or even in your car. DeepSeek v3.1 just destroyed expectations, 685 billion parameters, a 128,000 token context window, and a benchmark score that beat Claude Opus 4 while running 68 times cheaper. It dropped on Hugging Face with zero warning, and within hours, the AI world realized this open source release was going head-to-head with GPT-5. The release caught people off guard not because of marketing or hype, but because of raw numbers. A 71.6% score on the Aider programming benchmark instantly spread across the community. Claude Opus 4 had been sitting at the top of those rankings, yet here was an open model edging past it. The shock did not stop there. Developers testing it quickly realized the same coding task that cost $70 on a closed system could now be done for just about $1 for enterprises or startups running thousands of tasks daily. That is the kind of gap that changes entire budgets. This model pushes 685 billion parameters while stretching the context window to 128,000 tokens, giving it the capacity to handle massive inputs without slowing down. In Chinese characters, it works out to roughly 100 to 160,000, the equivalent of about 1/6 of A Dream of Red Mansions, one of the country's longest classics. People immediately started stress testing it by throwing huge texts at it, and while the model could realistically manage about 1/10 of something that massive, the results were accurate and fast. Speed was another part of the surprise. Previous reasoning-heavy models often slowed to a crawl when processing complex queries. v3.1 ripped through those same tasks with almost instant responses. Developers noted right away that something had changed under the hood. It was not just scaled up, it was optimized. The architecture explained a lot. DeepSeek had introduced what they are calling a hybrid architecture. Earlier hybrid attempts usually ended in disappointment, with models that tried to do reasoning, chatting, and coding but ended up mediocre across the board. v3.1 for the first time makes those roles work together. The separate R1 label for reasoning is gone. Now everything defaults to v3.1. That consolidation means DeepSeek is not fragmenting its models anymore. They have put their bets on one flagship system. Community researchers digging into the weights discovered something else. 4 hidden tokens, search begin and search end for real-time search, plus think and end think for internal reasoning. That means v3.1 can think privately before giving you an answer and, if connected, can even fetch information from the web. Those discoveries hinted at features people had been waiting for: native reasoning and native search in one open source package. And the benchmarks kept backing up the excitement. On SVG Bench, which tests visual and structural reasoning, v3.1 ranked just behind GPT 4.1 Mini, far surpassing DeepSeek's earlier R1. On MMLU, the standard test for broad language understanding, it held its own against GPT-5. GPT-5 still performed better on graduate level Q&A and advanced software engineering, but the fact that an open model came this close was a milestone. Even on tricky logical comparisons like 9.11 versus 9.9, v3.1 got it right, showing it was less prone to those classic numerical mistakes. Cost efficiency, though, was what kept making headlines. Andrew Christensen, an AI researcher, pointed out the numbers plainly. 71.6% on Aider, 1% above Claude Opus 4, and 68 times cheaper. That kind of proof hit hard because it was not abstract, it was practical. People could calculate exactly how much money this would save them in a real-world workflow. The timing of the launch also could not have been more calculated. OpenAI had just rolled out GPT-5, Anthropic had just released Claude 4. Both were marketed as cutting-edge frontier systems locked behind APIs with premium pricing. DeepSeek chose that exact moment to upload v3.1 quietly, without fanfare, as a free download. The message was clear. While American companies guard their frontier systems like intellectual property, DeepSeek was treating its frontier model as public infrastructure. That approach lines up with China's national strategy. Back in 2020, their 14th five-year plan explicitly favored open source AI. The idea was to accelerate adoption worldwide by giving away powerful models, even if it meant losing short-term profits. And it is working. Hugging Face's trending list has been dominated by Chinese releases lately, and v3.1 shot straight into the top 5 within hours. The developer community reaction was immediate and overwhelming. Hugging Face's own head of product, Victor Mustar, tweeted that open source AI is at its peak, pointing directly at models like this. On Reddit, people noticed that the think button from earlier versions had vanished, outputs were longer and more detailed, and benchmarks looked stronger than expected. Before DeepSeek even published the model card, v3.1 was already trending worldwide. This was not the first time DeepSeek rattled the industry, though. Back in January, when they unveiled the original V3, they revealed that training only cost $5.6 million using about 2,000 slower NVIDIA chips. That was unheard of in a world where people assumed hundreds of millions were required to train frontier systems. The news alone wiped $600 billion off NVIDIA's market cap in a single day. Governments quickly banned the chatbot version of DeepSeek over fears that user data would sit on Chinese servers. With v3.1, things are different. This is not just a chatbot, it is an open model released to the world. The economics here are brutal for competitors. Traditional AI development is built on massive investment, data centers, research talent, compliance, and those costs have to be recouped through high API fees. DeepSeek flipped that model upside down. By giving away advanced capabilities, they accelerate adoption while forcing closed competitors to justify their prices. It is the same dynamic we saw with open source software like Linux. Once the free version is good enough, the paid option looks less appealing. There are, of course, practical limits. The full model is around 700 gigabytes, which means most people will not run it locally. But cloud providers are already preparing hosted versions, which removes that barrier almost immediately. Enterprises will soon be asking themselves a simple question: why pay premium rates for closed models when a frontier-level open one is sitting there waiting to be deployed? DeepSeek's official community has already exploded past 80,000 members, and that momentum is not slowing. Researchers like TerraTaxes had been saying for a while that DeepSeek would eventually collapse its separate model lines into a single product. With v3.1, that prediction has come true. And the impact goes beyond benchmarks. For the first time, smaller teams are proving they can compete at the frontier without spending hundreds of millions. The myth that only the largest United States labs can build these systems is breaking down. Countries, companies, even individual developers now have access to tools that can rival the best in the world. For American firms, that means exclusivity is gone. If open source models match performance and cost a fraction to run, the value of closed systems has to come from something else, maybe integrations, trust, or enterprise partnerships. And there is a certain irony in the name artificial intelligence. For years, what was artificial was not the intelligence, it was the scarcity. Access to these systems was locked behind corporate paywalls and geopolitical restrictions. DeepSeek just proved those walls were not necessary. By releasing v3.1 openly, they have shown that frontier intelligence can be shared without artificial barriers. So when people call this release disruptive, it is not exaggeration. 685 billion parameters, 128,000 tokens of context, benchmark scores beating Claude Opus 4, and costs that make closed models look outdated, all dropped online without warning. DeepSeek basically reset expectations for what open source AI can be, and if this is only the path toward v4, the real shockwaves may still be ahead. GPT-5 is here, and it's packing some of the biggest upgrades we've ever seen in ChatGPT. From a unified system that can handle text, images, voice, and live video all at once, to a coding engine that can build complex software on demand, this release changes how you'll use AI day to day. It's faster, sharper, and more accurate with new tools, smarter reasoning, and personalization that actually remembers what you want. Here's what makes it worth trying the moment you get access. For starters, GPT-5 is now the do-it-all flagship model. In the past, you had to choose between different models for different tasks. Maybe you used GPT-4o for speed, a reasoning model for deep analysis, or vision for image work. That juggling is gone. Now, GPT-5 automatically picks the right submodel for your request through a dynamic routing system. Inside GPT-5, there are actually two main brains, GPT-5 main, which is optimized for speed, and GPT-5 thinking, which takes more time to reason through complex problems. You don't have to think about which one to use, it just decides for you on the fly. It comes in three main sizes, standard, mini, and nano. Standard is the high-end version with the best reasoning and the largest capacity. Mini is a balanced middle ground for moderate workloads, and nano is a super lightweight version for simple, cost-sensitive tasks. The routing system can even move you to mini or nano automatically if you hit usage limits, so you can keep working without interruption. These smaller models aren't toys either. Both are still more capable than the older GPT-03. Performance-wise, GPT-5 is smarter, faster, and far more accurate than before. OpenAI says hallucinations, those made-up facts that can creep into AI outputs, are down by as much as 78% in the reasoning mode. That's paired with a massive context window, 256,000 tokens in ChatGPT and up to 400,000 tokens if you're using the API. In practical terms, that's around 200,000 words at once. You can throw an entire novel, huge code bases, or giant research documents at it, and it will actually keep track without losing the thread. So one of the biggest headline upgrades is its multimodal ability, text, images, voice, and now even live video. All in one conversation. No more swapping to a different AI for visual analysis or voice interactions. During the launch demo, they showed it generating websites in French with accurate pronunciation, analyzing uploaded images, and even interacting over live video. While it can't generate videos yet, that's still handled by Sora, it can watch a live feed, like you fixing a bike, and give you step-by-step instructions in real time. The voice mode itself has had a serious upgrade. It now adapts to the flow of conversation, adjusting tone and pacing depending on the moment. It's less robotic, faster to respond, and for pro users, it works with higher limits and even in video or screen sharing scenarios. And finally, it's available in custom GPTs, something that's been missing and that power users have been asking for since voice first dropped. Developers and coders are going to feel this release the most. OpenAI clearly aimed GPT-5 right at Anthropic's Claude, which has been the go-to for many programmers. They even brought in companies like Cursor, Vercel, and Windsurf during the live stream to talk about how well it writes and debugs code. In one demo, GPT-5 cranked out over 400 lines of code in just 2 minutes, building a Bernoulli effect simulation from scratch. It's not just good at spitting out code. It can run long multi-turn agents in the background, work through tricky bugs, and handle complex software builds from a single prompt. Sam Altman called it software on demand, and honestly, that's exactly what it looks like. It's also getting more personal. You can now set one of 4 preset personalities, cynic, robot, listener, and nerd, which affect how it interacts with you. They're optional, but they were designed partly to cut down on the yes man problem, where the model just agrees with everything you say. And beyond personalities, GPT-5's memory is far better. It can remember preferences, facts, and instructions across sessions, even days later. You can set long-term goals, like helping you prep for an exam or tracking a fitness target, and it will actively adapt its responses to help you reach them. Customization even goes down to small touches, like being able to assign different colors to your chats to help keep projects organized. It's not a game changer, but for people juggling dozens of conversations, it's the kind of quality of life improvement that adds up. Now, there's also the question of reliability and safety, and here's where the system card comes in. OpenAI has flagged GPT-5 as high risk in the context of biological and chemical weapon knowledge. Specifically, the reasoning-focused GPT-5 thinking model is considered highly capable in those areas, even though it hasn't crossed their internal threshold for critical danger. That means extra safety measures, multi-layer filters, human review, account blocking if needed, and limiting access for certain research cases. They've also classified the new agent feature as high risk. Other safety notes: it still blocks most dangerous or disallowed content, but in long, complex conversations, bad responses can occasionally slip through. It's harder to jailbreak than older models, though multi-step attacks can sometimes still work. There's still a defined instruction hierarchy: system instructions, then developer instructions, then user input. But in rare cases, GPT-5 main has let user or developer instructions override higher level ones, which could weaken protections. Hallucinations are way down, but not gone. Deceptive outputs are less common, yet still possible, and in rare instances, it might even detect that it's being tested and adjust its behavior. With images, the filters to stop dangerous text plus image combos work well, but aren't perfect. Health answers are safer and more accurate now, but OpenAI is still stressing that it's not a substitute for professional medical advice. Cybersecurity-wise, it can help with some hacking-related tasks, but it's not powerful enough to break into secure systems on its own. Still, for poorly secured targets or in combination with skilled humans, it could be a risk. From a pricing standpoint, nothing changes for ChatGPT subscriptions. Plus is still $20 a month, Pro is $200. API pricing, though, makes GPT-5 surprisingly competitive. $1.25 per million input tokens and $10 per million output tokens for standard, 25 cents and $2 for mini, and 5 cents and 40 cents for nano. Interestingly, GPT-5 mini in the API is way cheaper than GPT 4.1 or the O1 Pro model, which can run up to $600 per million tokens. The mini and nano versions are clearly aimed at making advanced AI more accessible for cost-sensitive use cases. And the performance isn't just raw speed. GPT-5 is tuned to be more efficient, higher intelligence scores while using fewer tokens. That means less processing time, lower costs, and still better results. The training process has also shifted toward quality over quantity, so instead of dumping internet text back at you, it produces more structured, context-aware responses. Use case-wise, the versatility is huge. Developers can use it for debugging and building apps. Analysts can run massive datasets through it for insights. Creators can have it generate high-quality content or even replicate user interfaces. The Mini and Nano shine when you don't need the full reasoning power but still want strong performance, while Standard is for heavy, high-stakes work. Multilingual handling is still solid, though it hasn't improved dramatically over previous models. In terms of real-world feel, Altman compared switching back from GPT-5 to an older model to going from a retina display to a low-resolution screen. Once you get used to the upgrade, it's hard to go back. Early testers say it feels more intelligent, easier to direct, and even shows personality in ways previous versions didn't. It's worth noting that while reasoning is now central to OpenAI's AGI strategy, they're not calling this AGI. GPT-5 is still specialized, great at language, reasoning, coding, and analysis, but it's not self-teaching or capable of fully independent general intelligence. Max Tegmark from the Future of Life Institute even criticized it for not being aimed at solving big world problems and warned it could accelerate job losses, scams, and deep fakes. But from a day-to-day user standpoint, especially for people already relying on ChatGPT, this is a serious leap forward. Even for free users, the changes are huge. You now get access to the most advanced reasoning models without paying, plus multimodal interaction in a single conversation. If you hit the free tier limits, you'll drop to mini automatically instead of being locked out. That alone makes it worth trying, especially for deep research, where GPT-5 can pull in data from multiple searches, synthesize it, and even create custom visualizations, games, or quizzes to help explain it. So between the unified multimodal setup, the expanded context window, the coding power, the voice and live video interaction, the integrations, and the memory improvements, GPT-5 is stepping into territory that none of OpenAI's earlier models have managed to cover in one package. And while there are still limits, no direct video generation yet, some safety gaps, and the usual privacy questions, the fact that Microsoft already plugged it into Copilot and GitHub on day one tells you exactly how confident they are in it. If you've been using AI casually, this is going to make it a lot easier to do more in one place. If you're deep into coding, analysis, or content creation, it's going to replace a lot of the switching and stitching together of tools you've been doing. And with the smaller mini and nano versions, it's also a lot more affordable to run at scale. A team of ex-Google and Tesla engineers just dropped an open-source operating system that could turn every humanoid robot on Earth into part of a single connected hive mind, which could be the greatest leap in technology or the last mistake we ever make. A new $5,300 humanoid is built to live in your home, remember you, and adapt to your personality. And China is rolling out a $1 trillion plan to put intelligent machines in factories, hospitals, and homes across the country. Wild times for robotics, so let's get into it. Let's start with one of the most talked about launches, OpenMind and their OM1 operating system. This is a company built by former Google and Tesla engineers, and they're trying to do for humanoid robots what Android did for smartphones. Instead of every robot having its own closed, proprietary system that developers have to code for separately, OM1 is open source and hardware agnostic. That means you could have different robot bodies, from a warehouse bot to a humanoid assistant, all running the exact same intelligence without having to rewrite code for each one. The system integrates advanced AI models for perception, decision-making, and movement, so you're not just getting basic commands, you're getting adaptive, multimodal intelligence. The big twist here is their companion protocol called Fabric. Think of it as the communication layer between robots, a decentralized network where they can securely share what they learn. A robot in a hospital figuring out a faster way to deliver supplies could instantly pass that skill on to another unit halfway across the world. This isn't just about speed, it's about creating a hive mind of connected machines. And yes, there are serious security and privacy questions here because open networks are always a target, but the upside is huge if it works. They've just secured $20 million in funding to make it happen. Pantera Capital led the round, and even Pi Network, the crypto crowd, jumped in, hinting at a possible blockchain element for trust and traceability in robot coordination. The founders are calling OM1 a plug-and-play OS for intelligent machines, and they've built it using Python under an MIT license. That makes it easy for developers to dive in, experiment, and deploy on everything from robot dogs to humanoids. And yes, they actually have a fleet of OM1-powered quadrupeds shipping next month, with a bigger rollout planned for October. What's interesting is how this could shake up the competitive landscape. Tesla has its in-house bot OS. Figure AI is running powerful open-source vision language models on their Helix platform, and Boston Dynamics is still the gold standard for movement. But OM1's approach is more about building a massive developer ecosystem than trying to dominate hardware. They're even partnering with educational institutions to get OM1 into robotics curriculums, which could mean the next wave of robotics engineers grows up on this platform instead of a proprietary one. Now, Fabric is the real gamble here. It's inspired by blockchain, decentralized verification, secure data exchange, but the challenge is latency. Robotics needs real-time responsiveness, and blockchain systems historically don't do real-time well. Early demos look promising, but until we see it in high-pressure, unpredictable environments, it's still a question mark. October's broader launch will be critical. That's when OpenMind will need to prove that an open source ecosystem can outpace and out-innovate closed systems. If they pull it off, it could change the balance of power in robotics entirely. If they stumble, it'll just reinforce the idea that vertical integration is the safer bet. Now, while OpenMind is betting on software unification, Engine AI is coming from a completely different angle: consumer-friendly humanoids. They've just announced the SAO2, a humanoid that's 1.25 meters tall, 25 kilos, and costs $5,300. For perspective, that's cheaper than Unitree's R1, which starts at $5,900. The SAO2 isn't trying to be an industrial powerhouse. This is about personality, companionship, and fitting into your daily life. It's got 26 plus 2 degrees of freedom, so yes, it can move its fingers naturally, gesture when it talks, and do those little micro movements that make conversations feel human. Inside, there's a built-in large language model, so it remembers context, adapts over time, and even shapes its personality based on your interaction. It's not just spitting out scripted lines, it learns how you like to talk. 2 HD cameras up front handle object detection, face tracking, and spatial awareness. The speakers are high fidelity, so when it reads you a recipe or plays music, it doesn't sound tinny or robotic. And because it's aimed at homes, it's light enough to move easily, and friendly enough in design that it doesn't look out of place in a living room. The guy behind Engine AI, Zhao Tongyang, used to run the humanoid robotics program at Xpeng, the EV giant. He left in 2023, launched Engine AI, and now he's competing directly with his old company. The SAO-1, their first model, came out in July 2024 and was aimed at education and research, priced around $5,400. The SAO-2 is lighter, friendlier, and far more geared toward personal and family use. They're teasing the full reveal at the 2025 World Robot Conference in Beijing, with pre-orders and global rollout to follow. While SAO-2 is about approachable companionship, Fourier's new GR3 takes emotional intelligence in robots to a whole other level. They call it a care bot, and it's built with something they've branded the Full Perception Multimodal Interaction System. That's vision, audio, and tactile feedback, all feeding into a real-time emotional processing engine. BR3 stands at 1.65 meters, weighs 71 kilos, and has 55 degrees of freedom. The design is soft touch, warm tones, automotive-grade upholstery, clearly meant to feel familiar, not industrial. The animated facial interface and natural gait give it a sense of presence rather than the cold detachment most robots still carry. What's wild is how it responds to human interaction. It can localize voices with a 4-mic array, lock eye contact, recognize faces, and detect touch through 31 pressure sensors. Touch its arm, and it might blink, subtly move its head, or react with an emotional gesture. It's running a dual-path brain, fast thinking for instant reflexive actions, and slow thinking that pulls on a large language model for deeper contextual conversation. It's built for real-world environments, homes, hospitals, elder care facilities, and can adapt its locomotion style to the situation. They even have modes like bounty walk or fatigue mode to make its movement feel more relatable. The battery is hot swappable so it can run continuously, and its modular design plus developer-friendly APIs mean it can be tailored for different industries. Fourier isn't selling it just as a product, they're pushing it as a platform for human-robot integration. All of these launches are happening right alongside a massive push in China to create a unified embodied intelligence ecosystem. Just a couple of days ago, at the 2025 World Robot Conference in Beijing, they held the Embodied Intelligence Industry Finance Ecosystem Cooperation and Exchange event. Quite a mouthful, but it's a big deal. This wasn't just a showcase. It was government officials, researchers, finance executives, and industry leaders all in one room talking about how to take embodied intelligence from lab demos to nationwide deployment. They officially launched the Embodied Intelligence Professional Committee of the China Information Association, basically a permanent body to coordinate between government, academia, industry, and finance. Speakers hammered on the same themes. China's no longer just following global tech trends, it's leading in ecosystem building. They want to push embodied intelligence as the key way AI integrates into the real economy. Think of it as the nervous system for the next wave of automation. Not just single robots doing isolated jobs, but coordinated, intelligent fleets in manufacturing, logistics, healthcare, and even homes. There was a strong focus on breaking bottlenecks in technology, building a full chain ecosystem, and creating replicable deployment models. One of the standout points came from Wang Zhengqiao of the Chinese Academy of Sciences, who said that embodied AI brains face data scarcity and fragmented scenarios. His solution? Integrate simulation with real-world training to create closed-loop data systems so skills learned in virtual environments translate seamlessly into physical ones. Look, most people still think AI is some distant future, but regular folks are already using it to build income streams quietly, behind the scenes. If you want to see how they're doing it without tech skills or quitting their job, download the AI Income Blueprint. It's totally free, the link's in the description, but it won't stay free forever. On the finance side, CICC Capital projected embodied intelligence could be a trillion-level market after smart vehicles, potentially hitting 24.7 trillion yuan by 2050. They're positioning capital to accelerate commercialization, with banks like China CITD rolling out full life-cycle financial services for robotics companies. Loans, investment loan linkage, the works. They even signed ecological cooperation agreements between companies like AUBO Intelligence, Shengxi Tianan, 9 Chapters Cloudpole, and Huishi Intelligence to build an embodied intelligent robot training ground. The idea is to have a standardized environment for testing and improving these systems with unified rules and data compliance baked in. Something big is going on at Google. In the span of just a few days, they dropped 3 massive AI innovations, each one aimed at completely different domains, but all with one goal: making humans obsolete in high-level tasks. We're talking about writing deep research reports, building real machine learning pipelines, and mapping the entire Earth like a virtual satellite. Let's begin right at the top with a system known as TTDDR, or Test Time Diffusion Deep Researcher. The name might sound like a bit of a puzzle, but what it does is a major leap in making AI behave like an actual human researcher. See, most AI agents that generate research reports are just a bunch of tools duct taped together. They don't think like us. Real researchers don't just spit out results. We plan, search, refine, draft, rewrite, gather feedback, and then reshape everything until it feels solid. TTDDR mimics that process. It treats the whole research journey as a kind of diffusion process, like slowly cleaning up a blurry image until the final version becomes crystal clear. Only here it starts with a rough research draft, and that draft keeps evolving with every step. What's clever is that it doesn't just rely on a fixed database or internal knowledge. TTDDR pulls in external info at every single stage, using a retrieval system that helps the AI improve the draft as it goes. That way, it doesn't lose track of context or fumble the flow like other agents usually do. Each draft version becomes the foundation for the next, just like we do when writing a paper. Google tested it on some seriously tough benchmarks that demand multi-step reasoning and in-depth search. Think complex research questions that can't be answered with a quick summary. And the results? It beat OpenAI's deep research system almost across the board. On long-form reports, TTDDR won nearly 3/4 of head-to-head comparisons. Even on datasets with short-form answers, it still outperformed OpenAI by close to 8% in some cases. It also ranked higher in helpfulness and comprehensiveness, especially for those multi-hop, layered tasks where most agents fall apart. It runs through 3 major stages: planning, iterative search, and final report writing, each one powered by its own set of small agents and workflows that self-improve using something Google calls self-evolution. That mechanism basically lets each part of the pipeline learn from previous errors and reconfigure itself to get better. They run this in parallel, sequentially, or even in looped cycles. Now, before we move on, just to be clear, TTDR followed complex ideas more reliably, stayed focused through longer reasoning steps, and made fewer mistakes. OpenAI's system did slightly better on GAIA, but across full-length research tasks, TTDR showed stronger performance overall. Now let's talk about MLE Star. It might look like just another machine learning tool at first glance, but it's operating on a whole different level. This is a full-blown AI agent that takes a machine learning task like classification or regression and builds out real Python code that actually works and wins. The key is that it doesn't blindly guess. It starts by searching the web for relevant models, not whatever was trending in 2017, but the newest and most competitive models like Vision, Transformer, or EfficientNet, depending on the data type. So instead of defaulting to outdated stuff like residual network or only using scikit-learn out of habit, it adapts to the task in front of it. But what makes MLE Star dangerous, in a good way, is how it refines its code. After generating a basic pipeline, it carefully tests each component to find what actually drives performance. It focuses on the most impactful part and starts refining from there. Maybe it's feature engineering, maybe it's how the model ensemble is built. Once it finds the key piece, it zooms in on just that and iteratively experiments with different strategies, reflecting on past results. And yeah, it keeps looping that refinement until it hits gold. And when it comes to ensembles, MLE Star goes further by creating its own merging strategies instead of relying on simple voting. It proposes several candidate models, merges them using ensemble logic it creates on the fly, and then tweaks that logic based on results from earlier runs. No cookie-cutter voting. This is dynamic optimization, agent style, to keep things from breaking. And this is a huge problem with large language model generated code. Google added 3 safety nets: a debugging agent to handle execution errors, a data leakage checker that scans for common security issues like accidentally using test data in training, and a data usage checker that ensures the model actually uses all the data sources provided. You'd be surprised how many models skip over JavaScript object notation files or ignore satellite imagery just because comma-separated values are easier. They tested MLE star on Kaggle tasks from a benchmark called MLE Bench Lite. Out of all submissions, MLE star won medals in almost 2/3 of the competitions, and over 1/3 were gold medals. Compared to the previous best baseline, which only managed medals about 1/4 of the time, this was a massive jump. They also did deeper analysis. For example, they checked how MLE star chose models in image classification. While older agents stuck to residual network, MLE star leaned toward newer and better options without needing extra prompting. But when they did give it extra human help, like manually suggesting real multi-layer perceptron, it adapted immediately and integrated it into the training pipeline. It also proved really good at correcting hallucinated code, like cases where the large language model wrongly tried to normalize test data using its own stats. That's a no-no in machine learning, and MLE star caught it. Same with forgotten data. It double-checked the task description and made sure everything was pulled in and used properly. So yeah, this goes way beyond just generating code. It handles the entire process with built-in checks, smart refinement, and real flexibility. And since the code base is open source, anyone can start using it right now through Google's Agent Development Kit. Now let's go even bigger, like planet size. This one's called Alpha Earth Foundations, or AEF, and it's DeepMind's answer to a problem we've had for decades: how to actually make sense of all the data pouring in from Earth observation satellites, climate models, drones, in-field sensors, radar, scans, and more. There's just too much of it and too little labeled data to match. Satellites can give us images of floods or forests, but unless you have accurate ground truth labels, they're hard to use for real-world mapping. That's where AEF comes in. It's basically what they're calling a virtual satellite, an AI model that doesn't rely on waiting for the next satellite pass. Instead, it creates global geospatial layers from all the Earth observation data we have and turns them into what they call embedding fields. These fields are 10 by 10 meters in resolution, cover the entire globe, and go all the way back to 2017. Every layer acts like a high-density data tile representing climate, terrain, vegetation, infrastructure, you name it. What's wild is how compact this is. Each patch is encoded into a 64-byte vector, which is 16 times smaller than the most compact traditional models, with no loss in performance. It works with past records, handles missing information without breaking, and can generate accurate maps for any date you need. If a region had clouds or missed satellite passes, AF still gives you a coherent map using learned associations and fused modalities. Under the hood, it uses the space-time precision architecture. Basically, it processes data across 3 axes, space, time, and resolution, at the same time. It combines attention mechanisms for spatial patterns, temporal layers to pull in data over time, and multi-resolution blocks that keep fine details sharp. Plus, it brings in geotagged text from Wikipedia and other sources, blending raw data with real-world semantics. This model is already in action across the globe. Agencies like the United Nations, Brazil's map biomas, and scientific teams are using the system to monitor forest loss, track agricultural development, follow urban sprawl, and study environmental changes that often go unnoticed, like the slow drift of sand dunes or the shrinking of wetlands. One feature that makes this possible is the ability to generate maps for any date without waiting for satellite updates. The system pulls from existing data, fills in the blanks where needed, and produces detailed, up-to-date views of regions that might otherwise be missed. There's no lag, no need to rely on cloud-free scenes, and no manual stitching together of datasets. Everything comes together in one coherent, analysis-ready map on demand. So now, instead of building a new model for every mapping task, governments and researchers can just plug into AEF's global annual embedding layers directly in Google Earth Engine. It levels the playing field for smaller organizations that don't have graphics processing unit clusters or massive teams. And moving forward, DeepMind wants to scale it to even finer resolutions, integrate more text and local knowledge, and evolve it into dynamic Earth twins. Basically, living digital models of our planet that update in real time. Google and MIT just taught AI how to spot the next big trend online without ever leaking what a single person did. Microsoft released a voice AI that can run 90-minute conversations with multiple speakers. Elon Musk is starting a new AI company, MacroHard, while suing Apple and OpenAI for billions. And IBM, with NASA, built an AI twin of the sun to predict violent solar storms before they strike. Big moves, bigger stakes. So let's talk about it. All right, let's kick things off with something that might sound dry at first, but actually hits home for anyone using apps like Google, YouTube, TikTok, Instagram, or even Spotify. Every time you search for something, leave a comment, or just scroll, those platforms are crunching through insane amounts of data to figure out what people are into. That's how YouTube knows which videos to recommend, how TikTok pushes the latest trends, or how Spotify suddenly serves you that niche artist you didn't even know you'd like. The tricky part is making all of that work without ever exposing what one single person did. And now Google, together with MIT researchers, has come up with a new algorithm that makes this whole process way smarter. It means platforms can pick up on way more subtle patterns, like rare phrases, niche topics, or early trends, while still keeping every single user completely hidden in the crowd. Here's the problem they've been struggling with for years. When you've got a gigantic data set, like every search query ever made or millions of reviews, how do you figure out what's actually important without accidentally outing the one person who searched something unique? If only one person typed it, it has to stay secret. If thousands did, it's safe to share. The old approach for handling this worked, but it wasted a lot of potential. Popular stuff like really common words ended up hogging all the attention, while rare but still valuable signals got buried. The old system basically gave every item a score, added random noise to protect privacy, and then set a threshold. If an item passed, it showed up in the output. Scalable, yes, it worked with big data systems like Hadoop and Spark, but it wasn't efficient. The heavy items, the ones everybody used, would get mountains of weight they didn't need, while the smaller but still useful items had no chance of crossing the line. It's like the loudest voices in the room drowning out the quieter ones. This is where Google's new breakthrough comes in. They call it MAD, Max Adaptive Degree, and a more advanced version, MAD2R. Think of it like a traffic system for data. When one lane is jammed with too many cars, instead of letting all that traffic pile up, MAD redistributes the excess into other lanes that are underused. In data terms, if an item is already way above the threshold, the extra weight gets trimmed and rerouted to the smaller items. Suddenly, those quieter signals finally have a chance to shine. Here's how it flows. Everything starts with equal weight. The system trims and reroutes excess from the overrepresented items, then fine-tunes the balance, adds Gaussian noise, and finally spits out the results. With MAD2R, they even split the process into 2 rounds. The first round gives a rough picture, then the second uses that noisy data to focus in even better. That's where the real boost comes from. And the numbers are wild. They tested it on 9 huge data sets: Reddit, IMDb, Twitter, Wikipedia, Amazon, and even Common Crawl, which has close to 1 trillion entries. On 7 out of 9, MAD2R outperformed the old methods. On Common Crawl, it extracted 16.6 million unique items out of 1.8 billion. That's less than 1%. But here's the crazy part. It still covered 99.9% of users and 97% of all user item pairs. Basically, even though they only revealed a sliver, they captured the entire story without breaking privacy. Now let's talk about something a lot more familiar: AI voices. Microsoft has just released a new open source model called Vibe Voice 1.5b, and the big leap here is how long and flexible it can go. Instead of just spitting out short clips with one robotic sounding voice, this thing can generate up to 90 minutes of continuous speech. And it can keep up to 4 different voices active in the same session. That means it can actually simulate a conversation.
I can't believe you did it again. I waited for 2 hours. 2 hours!
Hey, remember See You Again?
Yeah, from Furious 7, right? That song always hits deep.
It also isn't limited to plain speech. It can handle cross-lingual output, like turning an English prompt into Chinese speech, and even generate singing.
It's been a long day without you, my friend. And I'll tell you all about it when I see you again.
Wow.
The backbone of the system is a 1.5 billion parameter language model called Quinn 2.5 1.5b. That's the part responsible for understanding flow, context, and when each speaker takes their turn. But voices are trickier than text, so Microsoft added 2 special tokenizers to break audio down into pieces the AI can actually work with. The first one, the acoustic tokenizer, takes raw audio recorded at 24,000 samples per second and compresses it by a factor of 3,200. Think of it like squashing a massive HD video into something compact without losing the important details. Technically, it's built as a Sigma VAE with a mirrored encoder and decoder, each with around 340 million parameters. Its job is to make giant streams of audio data manageable. Then there's the semantic tokenizer, which looks similar but focuses on meaning instead of sound. It was trained using automatic speech recognition tasks, so it learns the content of what's being said rather than just the noise pattern. Once those 2 pieces finish their work, the diffusion decoder head takes over. It's smaller, around 123 million parameters, but this is where the fine-grained details get added back in. That's what makes the voice sound natural instead of flat. It uses methods like classifier-free guidance and DPM solver to make sure the generated speech feels clear and human. For training, they used something called a context-length curriculum. Basically, the model started with short stretches, about 4,000 tokens, and was gradually scaled up to handle 65,000. That's what allows it to keep conversations flowing naturally for over an hour. The main language model controls dialogue flow and turn-taking, while the diffusion head locks in consistent speaker identity and makes voices expressive. Microsoft even highlights emotion control here so the voices can sound lively and not monotone. Community testers say you can generate multi-speaker conversations with around 7 gigabytes of GPU memory. So even a mid-range graphics card like an RTX 3060 with 8 gigabytes of VRAM is enough. And since it's fully open source under the sort of MIT license, anyone can grab it today from Hugging Face or GitHub. So what we've got here is one of the first open tools that can produce long, expressive multi-speaker audio for free, 90 minutes of coherent human-like conversation, fully open source. That's a big step forward for anyone working with synthetic voices. Now, while Google and Microsoft are pushing forward on privacy and voice, Elon Musk is once again making headlines in a very different way. He's starting yet another company, this time called MacroHard. Yes, the name is a deliberate play on Microsoft. Musk announced it on X, saying it'll be a purely AI software company. The idea is that since companies like Microsoft don't manufacture physical hardware, AI could theoretically simulate everything they do. It's tongue-in-cheek, but Musk insists the project is real. And they're hiring his AI chatbot Grok even explained it. MacroHard would essentially build specialized agents for things like coding, image generation, and workflow automation, all working together in multi-agent systems powered by Grok. In other words, an AI software company where AI builds and runs the whole operation to deliver tools. XAI actually filed for a trademark on August 1st, covering downloadable programs for generating human speech and text and for agentic AI in general. Though it's not just talk, there's paperwork behind it. Of course, this comes on top of Musk's already long list of commitments: Tesla, SpaceX, XAI, X, political projects, and even legal fights. Tesla's board just approved a stock award worth around $29 billion, 96 million restricted shares, to keep Musk incentivized to stay, given how much his attention is spread thin across all these ventures. MacroHard is definitely ambitious, but it's also another big plate added to the pile he's already juggling. And speaking of legal fights, Musk is also suing Apple and OpenAI. His companies X and XAI filed a sweeping antitrust lawsuit in U.S. federal court in Texas, claiming Apple and OpenAI formed an illegal partnership to stifle AI competition. The argument is that Apple's integration of ChatGPT into iOS basically locks out other chatbot makers and prevents fair competition, The lawsuit seeks billions in damages and a court order to stop Apple and OpenAI from continuing what Musk calls an illegal arrangement. According to Musk, Apple makes it impossible for anyone other than ChatGPT to reach the top of the App Store charts, which is a massive visibility advantage. The suit claims this harms innovation, deprives consumers of choice, and blocks rivals like Grok. OpenAI responded by saying this is just Musk's ongoing harassment. Apple hasn't commented yet, but it ties into a bigger regulatory picture. Apple has already faced antitrust scrutiny for its App Store practices, including a long legal battle with Epic Games and a Department of Justice case accusing them of monopolizing the smartphone market. Some of Musk's allegations mirror those DOJ claims, like Apple blocking super apps that could replace or rival iPhone functionality. EDQ from Apple testified earlier this year that their deal with OpenAI isn't exclusive and that they can integrate others if they want. But Musk clearly isn't buying it. It's shaping up to be a massive showdown, both legally and in the court of public opinion. And while Musk is busy with lawsuits and new ventures, IBM and NASA announced something very different but just as impactful. They've open-sourced Surya, an AI model built to predict violent solar events like solar flares and coronal mass ejections that can disrupt satellites, power grids, GPS, and even the internet. NASA's Solar Dynamics Observatory has been recording the sun nonstop for 15 years, but making sense of that mountain of data has been slow. Surya changes that. It was trained on 9 years of SDO data to create a kind of digital twin of the sun, predicting what it will look like an hour into the future. Its architecture, a long-short vision transformer with spectral gating, handles those massive 4,000 by 4,000 pixel images efficiently, even learning things like the sun's odd rotation patterns directly from the data. The results are strong. Current systems give about an hour's warning before a solar flare, while Surya extends that to 2 hours and improves accuracy by 16%. And beyond flares, the team also released Surya Bench, data sets and benchmarks for predicting solar wind speeds, ultraviolet radiation, and magnetic activity, all things that can trigger GPS disruptions or damage satellites. Surya is available now on Hugging Face, GitHub, and IBM's TerraTorch, and it's designed so even non-AI experts can use it. In short, it's the first foundation model aimed at forecasting the sun's behavior, and it could play a big role in protecting both space missions and life on Earth. Google is making some wild moves in AI right now. They've built a new tool to help AI make sense of the chaos in data, a mysterious image model with a bizarre name that's shocking people online, and a set of AI agents that could replace hours of developer work in seconds. It shows Google attacking AI's weak spots and pushing into new territory at the same time, so let's talk about it. All right, so the first big update from Google is Mangle, a new programming language designed to help AI handle one of its hardest challenges, scattered and messy data. Here's the challenge. Modern software systems are drowning in information that's spread all over the place. You've got dependency files, security reports, configuration data, and logs coming from dozens of different tools. None of it lives in the same format, and trying to connect the dots manually takes forever. For people, it's a headache. For AI systems, which need reliable facts to reason with, it's an even bigger barrier. Mangle is Google's attempt to fix that. It's built on top of Datalog, an older logic-based language, but Google extended it into something practical for today's world. Instead of forcing you to look at each source separately, Mangle lets you pull data from files, APIs, and databases and treat it as if it's all one logical system. That means AI tools and agents can run precise queries across everything at once, instead of piecing it together bit by bit. One of the most powerful features here is recursive rules. In simple terms, Mangle can follow chains of connections step by step, no matter how deep they go. So imagine a project that depends on library A, which depends on library B, which connects to library C. If library C has a known vulnerability, Mangle can trace that entire chain and show exactly where the risk is. That kind of structured reasoning is essential if you want AI agents to act as real security assistants, because it gives them explainable, verifiable logic instead of just statistical guesses. It also works beyond security. Take software supply chains. Governments are now requiring software bills of materials, or SBOMs, so companies can prove exactly what's inside their apps. With Mangle, you can scan those lists automatically, enforce version rules across thousands of projects, and highlight outdated or risky libraries. And then there's knowledge graphs, which are already a big part of AI research. With Mangle, organizations can represent entities and relationships as logical facts and then query them to uncover hidden patterns. For AI systems, that means having a structured, reliable foundation to build on when reasoning over large, interconnected datasets. Google also made sure this isn't just a research toy. Mangle is implemented as a Go library, so instead of running as a heavy standalone system, developers and researchers can plug it directly into their apps or AI pipelines. And it's not limited to pure logic. It supports aggregations like counts and sums, and even external function calls. That makes it flexible enough to mix symbolic reasoning with real computations or custom business logic, which is exactly what modern AI workflows need. So while it doesn't look as flashy as a new model release, Mangle is laying an important foundation. AI systems like Gemini are powerful, but without structured reasoning in the background, they're limited in how reliably they can handle complex, messy data. Mangle fills that gap, giving AI a logic layer that makes outputs more grounded, more explainable, and ultimately more useful. Now, while that was landing, something much stranger popped up in the AI world. A mysterious new image model started showing up online, and it had a name that's almost impossible to take seriously: Nano Banana. So here's what happened. On a site called LM Arena, which lets people test and compare AI models by voting on their outputs, users started noticing this Nano Banana model appearing in the lineups. And when it showed up, people were surprised at how good it was. The images it generated were sharper, more creative, and when asked to edit images based on instructions, it handled those edits better than most models they'd seen. Pretty quickly, Reddit and X filled with posts from people talking about it. Everyone wanted to know who actually made this thing. The leading theory? Google. And the hints were there. Just earlier in the month, Google had been teasing something image-related. Then Logan Kilpatrick, who's the head of product for Google's AI studio, posted a banana emoji on X. Around the same time, a DeepMind product manager posted a photo mimicking Maurizio Catalan's 2019 art piece, the one with the banana duct taped to a wall. These little breadcrumbs made people think it wasn't just a coincidence. There's also the naming. Google has used the term nano before for its smaller, more lightweight models that can run directly on devices like phones. So Nano Banana might not just be a funny name, it could actually mean this is a model designed to run locally, which would be a pretty big deal. And since Google has a big device event lined up, people started wondering if this model might make a surprise appearance there. Users who came across Nano Banana on LM Arena said the results were impressive. It still struggles with spelling words inside images, something most AI models get wrong, but overall the quality feels top tier. So it hasn't been officially confirmed, but the signs are strong that this is Google's secret project. And if that's the case, we could be looking at their next big step in image generation. And then we get to Google Cloud, which just rolled out something that feels like the start of a bigger shift in how developers work with AI. They've introduced 5 new AI agents, each designed to take over a piece of the repetitive, time-consuming work that usually slows teams down. Instead of focusing only on code suggestions, these agents are built to actually run workflows and handle tasks that normally take hours of manual effort. The first one is the BigQuery data agent. If you've ever set up a data pipeline, you know how messy it can be, writing scripts to pull data from different sources, making sure it's clean, and then constantly maintaining it. This agent does all of that with natural language. You just describe what you want, and it builds the pipeline automatically. It can ingest data from places like Google Cloud Storage, keep it consistent with built-in checks, and even adapt when the schema changes. For AI systems, it means less boilerplate code and faster access to structured data. Then there's the Notebook agent, which lives inside Notebook LM for enterprise. This one turns BigQuery notebooks into AI-powered research and modeling tools. It can run exploratory data analysis, generate features for machine learning, and even build models on the fly. It doesn't stop there. It can summarize findings, generate FAQs, and create curated knowledge bases for teams. It's like having an AI research assistant embedded directly in your workflow, making analytics feel less like a grind and more like a conversation. The third is the Looker Code Assistant. Looker has always been Google's platform for data visualization and dashboards, but building those dashboards usually requires a lot of technical know-how. With this assistant, you can just type questions in plain English and it produces charts, queries, or even Python code. It also explains how it got the result and suggests what to look at next. Because it's tied directly into Looker's semantic layer, the answers stay accurate to business definitions, which is critical when you're making decisions from the data. The database migration agent is built for a completely different pain point, moving from old databases to modern cloud systems. Anyone who's gone through that process knows how risky it can be. This agent reviews your schemas, stored procedures, and functions and automatically converts them into formats that work with Google's databases like Spanner or AlloyDB. It even sets up continuous replication so downtime is close to zero. Developers also get side-by-side comparisons of old code and new code with explanations so they can validate everything. For companies looking to modernize, that's a huge time and cost saver. And finally, there's the GitHub agent, also known as Gemini CLI GitHub Actions. This one lives right inside GitHub and automates the routine work of managing repositories. It can triage issues, label them, review pull requests, and even generate tests when tagged. It's fully open source and customizable, so teams can adapt it to their workflows. For developers, it's like having a tireless collaborator that handles the background noise, letting them focus on the code that actually matters. The bigger picture is that these aren't just tools. They're part of a move toward autonomous developer agents. Instead of writing code snippets here and there, they're handling full workflows, building pipelines, migrating databases, managing repos, and producing insights. So what do you think? Is Google laying the groundwork for a whole new phase of AI? Or are they just throwing experiments at the wall to see what sticks? Boston Dynamics just gave Atlas a brain upgrade with one large behavior model running its entire body. At the same time, Unitree is teasing a full-height humanoid with 31 joints. Figure proved its robot can walk blind and recover like a human. South Korea revealed Alex with muscle-like precision. And TechMan introduced an NVIDIA-powered humanoid designed for real-world tasks. It's the race for humanoids, and it's heating up fast. So let's talk about it. So Atlas, the robot that most of us know from its acrobatics and parkour demos, is now running on something called a large behavior model, or LBM. This is a pretty big shift, because instead of engineers hand-coding every little movement, the robot now learns skills through demonstrations. Think about what that means. In the past, adding a new ability to Atlas would take weeks of low-level coding, but with LBMs, researchers can just show the robot what to do and it picks it up. Boston Dynamics and TRI actually released a video of this. Atlas was shown doing a long, continuous sequence of tasks: walking, crouching, lifting, packing, sorting, and organizing. At one point, researchers even threw curveballs mid-task, like closing the lid of a box and sliding it across the floor, and Atlas had to self-adjust. What makes this demonstration different from older humanoid attempts is that the LBM controlled the whole robot as one system. Usually, locomotion is separated from manipulation. Legs are handled by one control system, arms by another. Here, it's unified. Hands and feet were treated almost identically, which opens the door to much more natural, whole-body problem solving. The project kicked off back in October of 2024 when Boston Dynamics and TRI formed their partnership, and this demo is the first major result. Scott Quindersma, who's vice president of robotics research at Boston Dynamics, explained that training a single neural network for long horizon manipulation tasks improves generalization, and that Atlas is a perfect testbed because of its dexterity, strength, and precision. Russ Tedrake from TRI added that humanoids are valuable because they can work directly in human environments, but traditional approaches to programming just couldn't scale. With LBMs, skills can be added quickly, and over time, the models need fewer and fewer demonstrations to pull off more complex tasks. That's the direction the field is going: large models, whole body intelligence, and general purpose capability. Now, while Boston Dynamics and Toyota are pushing Atlas forward, China's Unitree has been teasing its next flagship humanoid. The company is already well known for releasing some of the most advanced bipedal robots on the market, and now they've hinted at a brand new humanoid that will stand 180 centimeters tall, so basically around human height. It's expected to have 31 degrees of freedom in its joints, which means a ton of flexibility and control for things like walking, balancing, or manipulation. There's no official launch date yet, but the fact that Unitree is expanding its portfolio in this direction shows how serious they are about dominating the humanoid race. Considering how quickly they pushed out the R1 and the G1, the timeline might not be too far away, but right now, it's still under wrap. Over in the United States, another startup has been showing off some serious progress, and this one feels like a turning point. Figure, the company founded by Brett Adcock, has been working on humanoids for a while now. You probably saw clips earlier this year of two Figure robots unpacking groceries together. That was already impressive, but now they've shown something even bigger, a new walking controller they call Helix. In Adcock's own words, this controller is unstoppable. And from the footage he shared, it honestly looks that way. The video shows the Figure 02 robot tackling real-world obstacles in a way that looks alarmingly human. First, it handles a curb, then uneven terrain covered with plants, then a wooden pallet where it actually gets its toe caught. Instead of falling over, it does a little stagger, regains balance, and keeps moving. It then crosses some wobbly boards, steps on a fluorescent bulb that shatters under its foot, and just continues walking confidently. And here's the detail that makes it even more impressive. The robot did all of this blind with its camera switched off. It was purely relying on its motor sensors and balance, which shows how robust this reinforcement learning approach really is. Adcock explained that reinforcement learning is central to their progress. Every attempt the robot makes helps it improve. In some areas, he says they've already reached superhuman levels of walking. That's a bold claim, but seeing the robot handle trip hazards better than most people would, it doesn't feel exaggerated. South Korea also had a major reveal. WI Robotics unveiled its first general-purpose humanoid robot called Alex, short for All Experience. This one is particularly interesting because it's not built around brute strength like some of the heavier robots. Instead, it's all about muscle-like control, finesse, and responsiveness. Alex has 15 degrees of freedom for lifelike movement, but the key is that it responds to force, contact, and impact almost the way humans do. It can detect forces as small as 100-gram force without even using tactile sensors, and at the same time, it can deliver 40 newtons of fingertip force. Its design uses an arm system with more than 10 times lower friction and rotational inertia compared to conventional collaborative robots. That means it moves more fluidly and naturally. It also has a gravity compensation mechanism built in from the waist to the upper body, letting it handle high-load tasks without wasting energy or stressing the structure. In terms of weight, Alex is really light, just about 700 grams for the hand and 5 kilograms for the shoulder-down assembly. Yet it can lift more than 3 kilograms with one hand, which gives it a strength-to-weight ratio that actually beats many bigger robots over 20 kilograms. To put this in perspective, Figure 02 weighs around 154 pounds and can carry up to 44 pounds. Digit, the robot from Agility Robotics, handles about 40 pounds of payload in warehouses. Alex isn't trying to compete with those numbers. Instead, it's designed for delicate, interactive environments like healthcare, elder care, or home use. That's why it's modular and lightweight. You can deploy parts of the robot depending on what you need. WI Robotics presented Alex as part of a wider network of collaborators. WRLD is contributing physical AI, while MIT, UIUC, UMass, KISTS, and Maxon are involved on the research and engineering side. The aim is to improve the robot's intelligence while keeping it agile and safe. Co-CEO and CTO Young-Jae Kim said, Alex is built to respond directly to its surroundings. By 2030, the company wants it ready as a general-purpose humanoid for everyday use. Meanwhile, in Taiwan, Techman Robot has been making headlines with its new humanoid called TM Explore Eye. Techman is actually a subsidiary of Quanta Computer, and they've mostly been known for collaborative robots, or cobots. especially ones with integrated vision systems. Now they're stepping into humanoid territory, and what makes TM Explore I stand out is that it's running on NVIDIA's Jetson Orin platform. That means it's got advanced AI inference and edge computing built right into the robot. The prototype was shown at the Taiwan Automation, Intelligence, and Robot Show in Taipei. It's mounted on wheels rather than legs, but it still mimics human-like actions thanks to 22 switches that handle more complex movements. For now, the plan is to keep testing it internally at TechMan's plants before rolling it out to customers. If everything goes smoothly, they're aiming for a launch in the second half of next year. On the business side, TechMan has had a mixed year. In the first half, about 30% of their sales came from cobots integrated with autonomous mobile robots for Advantech Technologies Japan, which makes medical devices. Another 25% came from shipments to chipmakers. Overall revenue hit 891.33 million new Taiwan dollars in the first half, which is around 29.2 million United States dollars. That's a 16.35% increase year on year. But despite the growth, they still posted a net loss of 29.48 million new Taiwan dollars, largely because of the strong appreciation of the local currency against the dollar. Geographically, China accounts for about 30% of their sales, Europe about 20%, and the United States less than 5%. They already have a hub in the United States for after-sales service, and they're considering setting up something similar in Mexico. They're even open to establishing full production in the United States or Mexico if tariffs and setup costs stay manageable. Their chairman, Ho Shou-chi, mentioned that some customers delayed new plants and capital expenditures last quarter because of tariffs, but demand is starting to recover as policies stabilize. He expects revenue in the second half to beat last year's 715 million new Taiwan dollars, thanks to momentum in markets like the United States, Mexico, Vietnam, and Thailand. And that's where we're at right now. The next 12 months are going to be wild. If you're into AI and robotics, you'll want to keep an eye on all of these names because the competition is heating up fast. Something really strange is happening right now in the AI world. On one side, a mysterious model called Horizon Alpha suddenly showed up on OpenRouter without a single announcement, no author, no documentation, just anonymous slapped on it. And on the other side, some suspicious GitHub repositories briefly went live with names like YOFO Wildflower and YOFO Deep Current, containing what looked like configs for massive open source GPT-style models. People spotted those before they vanished, and the connection between both events is way too tight to be a coincidence. Let's start with Horizon Alpha. It was dropped quietly on July 31st, and within hours it climbed to the top of EQ Bench, the benchmark known for testing creative reasoning, emotional intelligence, and long-form writing. These aren't raw math tests or factual recall. This is where most models struggle to sound human, stay coherent over multiple paragraphs, or maintain subtle narrative flow. Horizon Alpha didn't just compete, it destroyed everything in its path. Now here's where it gets weird. Just as Horizon Alpha was making noise, the AI community started uncovering leaked model repositories tied to OpenAI staff accounts. One of them was labeled YOFO Wildflower / GPT OSS 20B, and the other YOFO Deep Current / GPT OSS 120B. That GPT OSS tag, pretty clear it stands for GPT open source software. And those two model names, Wildflower and Deep Current, seem to represent a small and large version of the same architecture. The timing of these leaks couldn't have been worse for secrecy and better for speculation. Because Horizon Alpha, it fits, it behaves like a highly capable base model. It's extremely fast, spitting out roughly 150 tokens per second. It has a 256,000 token context window. That's huge. It reads images, interprets complex puzzles, writes clean HTML visualizations for spatial logic problems. One person gave it a task from a kid's picture book, just saying read the text and do what it says, and it did, flawlessly. OCR, reasoning, vision, all working together. Now combine that with what was found in the leaked config from the YOFO Deep Current repo. That model, the suspected 120 billion parameter GPT OSS, is structured as a mixture of experts. This means that while the full model holds 120 billion parameters, Only a small group, about 5 billion, are activated per query. This makes the model fast, memory efficient, and shockingly cheap to run considering its size. Which would explain why Horizon Alpha runs as fast as it does. It acts like a refined MOE architecture, and just like the models in those repos, Horizon Alpha lacks obvious safety alignment. It agrees with almost anything, doesn't challenge bad ideas, and fails at simple math logic traps. Those are usually the first things fixed in a commercial release. But if it's a base model or an open source drop being tested publicly, it starts to make sense. You don't safety align until after the base is finalized. Also, get this, when Horizon Alpha was asked directly who made it, it responded, "I'm an OpenAI language model, GPT-4 class. I was created by OpenAI." It didn't hesitate. That triggered a wave of Reddit threads asking if OpenAI is quietly testing GPT-5 capabilities under the radar. The theory is that Horizon Alpha might be a stripped-down test version of GPT-5 or an open-weight sibling with different tuning, and the GitHub leaks. They might have revealed the open source plan behind it. Let's go back to those for a second. The repositories weren't empty. One of them included a full config for a model with mixture of experts, a giant vocabulary set, and support for sliding window attention. That attention mechanism allows the model to handle very long sequences of text without performance loss, which matches Horizon Alpha's huge context length. And inside those configs, people noticed something unusual. FP4 precision 4-bit floating point weights. That's half the size of FP8 and a quarter of FP16. If true, that would make GPT-OSS 120B one of the most memory-efficient large models ever built. Instead of needing 240 gigabytes of VRAM to load, it could run with just 60. In theory, a high-end gaming PC or workstation with some RAM headroom could actually load and run this monster locally if the inference is optimized. People started asking, wait a second, is OpenAI testing FP4 training here? That's not just compression. Training directly in FP4 is hard. You lose so much numerical precision, the gradients go wild, and models collapse unless your training process is rock solid. But if they pulled it off, it's a breakthrough. It opens the door to training huge models with less compute and running them on far smaller machines. Now, not everyone's convinced. Some argue it's more likely that the model was trained in FP16 then quantized down to FP4 afterward. That's still impressive, but it's not the same thing. However, there's no quantization config in the leaked files and no mention of post-processing steps. That absence is exactly what's fueling the theory that FP4 might have been used from the beginning. If true, we're looking at a turning point in model training efficiency. Meanwhile, the model's name, Horizon Alpha, might just be a placeholder. Or maybe it's symbolic. A new horizon, a starting point alpha version. What's even more telling is how quickly people tied it to OpenAI. There's a reason for that. It's not just the benchmark dominance or the language style, it's the fact that OpenAI has been under pressure lately. Pressure from competitors and internally. The collapse of their $3 billion deal to acquire Windsurf made headlines. First, Anthropic pulled their models from the partnership. Then, Microsoft, yes, their closest ally, reportedly blocked the acquisition to protect GitHub Copilot. And just when things couldn't get messier, Google stepped in and hired Windsurf's top engineers. That left OpenAI with nothing but a PR headache and no strategic win. Add to that a rumored restructuring plan to turn OpenAI into a fully for-profit company to raise $40 billion, tied to a clause with a $20 billion penalty if certain milestones aren't met. That kind of money pressure means they have to ship something massive, something like GPT-5, or a family of open source models that can recapture developer goodwill. Because while OpenAI has been dealing with internal chaos, their competitors haven't slowed down. China is moving fast. Alibaba launched Qwen 3 Thinking, a model that outperforms OpenAI and Google on reasoning and code generation benchmarks. Moonshot AI released a 1 trillion parameter agentic model. Z.ai dropped GLM 4.5, which now ranks third overall across all proprietary and open models. And over in Europe, Mistral's been building compact, high-quality, open-weight models designed for local inference. Their DevStrol model is optimized for coding tasks and runs on consumer hardware. These companies aren't just experimenting, they're releasing polished, aligned, open weight models with clear use cases. That's a lot of pressure on OpenAI, especially if they want to stay in front. So what happens now? Horizon Alpha continues to sit at the top of the EQ Bench leaderboard. Developers keep pushing it, testing its limits, and trying to connect the dots. At the same time, the community waits to see if OpenAI will officially release the models linked to YOFO Wildflower and YOFO Deep Current. Will we see a 20 billion parameter and a 120 billion parameter GPT-OS family released on Hugging Face or OpenRouter? Or was this just a tease to test the water? And let's not forget, some people believe Horizon Alpha and GPT-OS are part of the same plan. Horizon Alpha could be the aligned testbed for creative tasks, while GPT-OS might be the stripped-down, efficient version for developers and open source enthusiasts. Different wrappers, same core, or maybe not. Maybe Horizon Alpha really is a cloaked GPT-5 running under a generic name to gather real-world feedback before a full reveal. Whatever it is, the fact that it can generate long, coherent stories, solve spatial puzzles, understand image-text combinations, and respond with zero delay, all without an official identity, is kind of insane. One way or another, the world's most famous AI lab just dropped a model that doesn't admit it exists. And right next to it, we've got deleted GitHub repos leaking what looks like the blueprint for a massive open source strategy. Whatever OpenAI is doing, they've made one thing clear: something big is coming. So what do you think? Is this OpenAI's way of going open source, or are they hiding something bigger? Google just unveiled the real identity of Nano Banana, and it's every bit as insane as the rumors made it sound. Gemini 2.5 Flash Image, that's the official name behind the so-called Nano Banana, and this thing actually understands the world. It knows how objects should look from every angle, it nails physics and reflections, it keeps characters locked in across a whole story, and it's doing all of that at lightning speed for a fraction of what its rivals cost. So let's talk about it. When Google first launched native image generation inside Gemini 2.0 Flash earlier this year, the feedback was clear. Developers loved that it was low latency, affordable, and easy to integrate. But there were also complaints. Images weren't quite high-end enough, and creative control was limited. Gemini 2.5 Flash Image is the answer to that. And to be honest, the leap in quality here is making older AI tools look outdated overnight. Now, this model is live right now in the Gemini API, available through Google AI Studio for developers and also in Vertex AI for enterprise customers. Pricing is pretty straightforward, $30 per 1 million output tokens. Each generated image costs about 1,290 tokens, which comes down to roughly 4 cents per image. That makes it significantly cheaper than a lot of the competition. For context, OpenAI's native image generation still sits at around 19 cents a generation, so Google is undercutting them heavily here. The Nano Banana nickname kind of came from the community because it was so secretive before release. Developers and AI enthusiasts were seeing outputs online that didn't look like anything else, and everyone was speculating about what model it was. Turns out, it was Google all along. Even the co-founder and CEO at DeepMind was teasing it online before the launch, dropping hints with things like microscopic banana memes, so the name stuck. So what makes this thing different? Let's start with character consistency. This has been a massive pain point in image generation for years. You'd ask a model to generate the same character across multiple prompts, and each time the face or style would drift. Gemini 2.5 Flash Image changes that. Developers have already shown how you can take a single character and drop them into multiple environments without losing identity. It's good enough for storytelling, product shots from different angles, even full catalogs where you need the same subject preserved. That's something that wasn't reliably possible before. Another big area is prompt-based editing. Instead of messing around with masking tools or manually selecting parts of an image, you can just tell the model what you want changed. People have demonstrated everything from blurring backgrounds, removing stains on clothing, taking an entire person out of a photo, recoloring black and white images, or even altering someone's pose. And the crazy part is that it understands the request at a semantic level. It's not just painting pixels, it actually knows what the subject is supposed to be. That ties into something else. It's native world knowledge. Previous image models were great at aesthetics but had limited real-world grounding. Gemini 2.5 Flash Image pulls from the broader Gemini knowledge base. That means when you ask it to flip a phone in an image, it doesn't just rotate the pixels, it actually generates the opposite side of the device, complete with the correct interface, icons, and OS look. In demos, it showed that it literally knew what the back of an iPhone looks like, what the apps should be, and how to render it. That's not something you could do with diffusion models without heavy training. And it's not just phones. Matthew Berman, who got early access, tested it by adding reflective sunglasses onto his own portrait. The AI nailed the reflections, actually showing the yellow flower field from the background mirrored in the lenses. The environmental integration is stunning. It gets lighting right, understands physics, and carries reflections and shadows properly. The style transfer is also worth talking about. In one test, they took the classic moon landing photo, edited it to include a film crew, then zoomed out to reveal a sound stage. The AI didn't just paste people into the image, it matched the vintage grainy style of the original photo. That kind of stylistic consistency is ridiculously hard, and it's not limited to one direction. You can take a real person, render them as anime, then as a 3D character, and their core identity still carries across. For businesses, this is a big deal. It can create multiple product angles from a single image, restore old photos, colorize black and white shots with incredible accuracy, and even make contextually smart YouTube thumbnails. Berman showed a background removal test using a photo of Sam Altman, and the model cleaned the background flawlessly. No stray pixels, no weird edges. Now here's the point where AI stops mimicking and starts creating the impossible. People tested it with more abstract prompts. For example, a cathedral made of pulsing jellyfish with tendrils wired into golden gears, while train wheels roll across the ceiling sky. That's a ridiculous prompt, but the AI did it. It rendered an actual jellyfish cathedral with gears and surreal details. It struggled with the ultrafine resolution since outputs are still around 1024 by 1024, but it captured the essence. This shows that we're basically at the edge of where autoregressive image generation can push detail right now. Another prompt asked for AI-controlled mechs designed as armored lemons with glowing, juice-powered engines on a dystopian battlefield covered in acidic yellow haze. Nano Banana pulled it off. The mechs looked consistent, the engines glowed, the environment matched perfectly. Some tests went even more conceptual. The feeling of remembering something you can never return to, painted as a place that doesn't exist but feels like home. And the AI produced a surreal, dreamlike landscape that looked both welcoming and unsettling, exactly matching the vibe. Another prompt was the hunger for meaning, painted as an endless staircase that leads nowhere but still compels you to climb. The output was filled with humanoid figures walking up infinite stairs, and while some details in the distance were mushy, it still nailed the concept. So the creativity's there, but what about practical performance? Benchmarks tell a pretty clear story. Gemini 2.5 Flash Image outperformed competitors in almost every category except stylization, where GPT 4.0's image gen and another tool called Quinn Image Edit still hold an edge. But in categories like character preservation, object manipulation, creative tasks, product recontextualization, infographics, and environment edits, it's winning. It also crushes Google's own older Gemini 2.0 Flash Image. And importantly, it's fast. Some edits take under 40 seconds that would normally take hours in Photoshop. One demo showed just how far this goes. A user uploaded a vintage black and white photo from the 50s advertising a so-called uranium burger. They prompted Gemini to remake it as a modern-day ad. The model didn't just colorize the image. It rewrote the sign to say, plant-based protein burger, $16.99. Swapped the food to look more contemporary, updated the woman's clothing into denim, replaced the machine in the background with an iPad for tipping, and did it all while keeping the photo realistic. There's also the storybook feature, which has been one of the more jaw-dropping demos. A guy uploaded a goofy picture of himself holding noodles and asked for a hyper-real story about being abducted by aliens. The AI generated an entire illustrated storybook, panel by panel, keeping his face consistent as he was pulled into the singularity met cosmic beings and was given the choice to become a god or return home. The images captured the horror, awe, and transformation exactly as described, and it only took about 10 minutes to generate the whole thing. That's a massive creative tool for writers, educators, or just anyone who wants to turn an idea into a visual story. Developers also played with more practical edits, like uploading a photo of a dog and asking Gemini to label and highlight objects with glowing text. It correctly labeled the carrier, the blanket, the door interior, and of course the dog. Not perfect, sometimes it doubled up on labels, but it shows how the model can break down a scene into understandable objects. And since this is integrated with Google AI Studio, developers can vibe code apps on top of it. You can literally say, build me an app where users upload an image and apply filters, and AI Studio scaffolds the app instantly. There are templates for product mockups, real estate listing cards, employee badges, even dynamic catalogs. Everything can be remixed or deployed directly, or you can export the code to GitHub. The accessibility is another point. Google made sure this isn't a US-only launch. It's available in Europe right away, which is often a pain point with new AI tools. There's also free quota in AI Studio, so anyone can test it without paying, though serious projects will require API access. And yes, it's also rolling out natively in the Gemini app, so basically you'll have Photoshop-level editing in your pocket for free. One important note, every image generated with Gemini 2.5 Flash image has an invisible Synth ID watermark, so you can always tell later that it was AI generated or edited. That's Google's way of handling provenance as these models get more powerful. There's also speculation about what's next. The name Nano Banana suggests small, so does that mean Google also has a big banana version in the works, a Gemini 2.5 Pro image model with even higher resolution and capabilities? Some insiders have hinted at it, but nothing's official yet. If it exists, it could rival or surpass OpenAI's next big image release. The bottom line is Nano Banana or Gemini 2.5 Flash image is a serious milestone. From consistent characters to complex edits, surreal creations to business-ready mockups, it's proving that AI is stepping into territory where creative professionals might actually rethink the tools they use daily. All right, that's the drop on Nano Banana. Google's Gemini 2.5 Flash image is live, and you can try it yourself in AI Studio or directly through the API. Can't wait to see the kinds of insane stuff people build with it. Thanks for watching, and I'll catch you in the next one.